In these problems, we are finding limits of some trig functions by using some special trigonometric limits. So they're just telling us that the limit as x approaches 0 of the sine of x over x is 1. Maybe later on you'll get a proof of this. You'll see how we arrived at this idea, but for right now you're just using this fact. And you're using this fact too. The limit as x approaches 0 of the cosine of x minus 1 over x is 0. So what we want to do when we're given an expression like this, the limit as x approaches 0 of 5 minus 5 cosine x over x, is try to make it look like one of these, manipulate it algebraically to arrive at one of these, or perhaps to arrive at some values you can just evaluate the functions at, or a combination. So let me see, what would I do with this one? So I've got the limit as x approaches 0 of 5 minus 5 cosine x. I think I'm going to pull out the 5. So that would leave me, actually I'm going to pull out a negative 5. Yep, that would leave me with a negative 1 and a plus cosine x. And that's all over x. Now the reason I did that is because this expression is the same as cosine x minus 1. When I've got a multiplier out here, I can pull it out in front of the limit. So now I have negative 5 times the limit as x approaches 0 of, and I'm going to rewrite the top here, the cosine of x minus 1 over x. That's exactly what this is. So that is 0. This limit is 0. So I've got negative 5 times 0, which is just 0. So that one is done. Let's try a slightly more involved one. So here we've got x plus 5 times the tangent of x over the 2 times the sine of x, and we want to find that limit as x approaches 0. So there's two terms on top. I think actually I'm going to take this approach. I'm going to write this as two separate fractions, putting them over the same denominator. So x over 2 sine x plus 5 tan of x over 2 sine x. And of course, this is the limit. Let's take this chunk, because if we find the limit of this, we can add it to the limit of that. I'm going to pull out a 1/2. So this is the limit as x approaches 0. And I can pull out this one, I mean, you can think of there being a 1 up here. I'm pulling out the 1/2, so that goes away. And now I've got 1/2 times the limit, and I'm just working on this first chunk now, as x approaches 0 of x over sine x. And you might say, what good is that? We want sine x over x. Well, x over sine x is the reciprocal of that. So I could rewrite this as 1/2 times the limit as x approaches 0 of 1 over sine x over x. Now that's actually useful because we know that the limit of sine x over x is 1. So this part can be 1, and we have 1/2 times 1 over 1, which is just 1/2. So this chunk, the first little chunk, came to 1/2. I'm going to jot that down here. Let's work on the second chunk. This one's maybe not as easy to see what to do. Well, I can pull out a 5/2 just like I did before. So we're taking the limit as x approaches 0, and I'm going to pull out that 5/2 and put it out front here. And then we've got the tangent of x over the sine of x. And let's see, the tangent of x is the sine over the cosine, so we can write that out. And then we've got the sine of x down here. I see what I can do. I can multiply the top and the bottom by 1 over sine x, which is really just multiplying by 1. And that'll cancel, and that'll cancel. And what we are left with there on the top is 1 over the cosine of x, and on the bottom is 1, so I won't even write it. So we've simplified that. I've still got this chunk, so let me re-add that. So 5/2 times the limit as x approaches 0 of 1 over the cosine of x. And you might say, what good does that do me, because it doesn't look like that at all. However, we can actually evaluate this. This cosine function is continuous at 0, which is where we're trying to compute this. The cosine of 0 is 1. So this is 1 over 1. So this part is 5/2 times 1 over 1, or just 5/2. So we've got 1/2 and actually plus, right? Because these were added together. 1/2 plus 5/2 is 6/2, or 3. Whew. So we got there. That's a little bit of work with finding limits using these special trigonometric limits.